Guten Morgen allerseits. Ja. Mein Name ist Donovan Brown, Principal DevOps Manager für Microsoft. Vielen Dank für den Beitritt zu mir heute Morgen. Ich spreche nur ein bisschen Deutsch. Jetzt spreche ich Englisch, danke. Some of you, if you follow me on Twitter, know me as the manager of the League of Extraordinary Cloud DevOps Advocates. It was a nickname given to us, but most people just call us the League. We are a collection of cloud advocates that span dev and ops, Windows and Linux, VSTS to Jenkins, and containers to app service. Our job is if you want to run your code in Azure, we have to make sure you can do it with DevOps best practices for any language targeting any platform. We are very, very active on Twitter. We're not stupid like Trump on Twitter, but we're really active on Twitter. And if you want to get a hold of us, you can actually use that hashtag. It's sort of like our bat signal, because when you use it, the entire team gets a notification letting us know that you need our help. We have a team room that lights up and lets us know that someone in the world just tweeted with that hashtag. The entire team will go and read that hashtag and make sure that we can help you. And if we can't, we will reach inside of Microsoft and add someone to the conversation that knows the answer to your question. We are very serious about connecting with our customers via Twitter, and I encourage you to use that hashtag whenever you need our attention. DevOps is something very important to us at Microsoft. It has transformed the way that we do business. And we want to enable our customers to do the exact same thing. And if you ask us at Microsoft, what does DevOps mean? We say it means this. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. Value is the most important word. It is not about getting to the end of your product backlog. It is not about implementing that hot new feature. It is about continuously delivering value to your end user. I believe that this will completely change the way that you interact with your customers. I recently found a video that I think really articulates what your company can look like before and after it implements DevOps, and I want to share that video with you right now.
But Holland comes in for a pit stop. Time to refuel and change tires. Lou Moore himself changes the tires. Only 4 crew members, including the driver, are allowed to work on the car. It's a tense time. Holland stays in his seat, anxious to get away. Let's watch. Tires are changed at last. A crewman polishes the windshield as Holland moves away just 67 seconds after he stopped.
Exactly what we tried to do at Microsoft. We tried to stop swinging hammers at our software and become really, really efficient at the way that we do it. I was so impressed with this video that I actually tweeted it. And generally, most people got the point that I was trying to make. But 2 people in particular said that the second pit stop didn't add any value, which I found very hard to understand. Of course the second pit stop was faster. Look how many more people were involved. Thinking, well, that's not really the point, but okay. Look at the second pit stop. They didn't refuel the car. Of course it didn't add any value. I think, man, you're really missing the point. And I remember reading this, and I'm in my office, and I'm really upset. My wife comes in, she says, what's wrong? I'm like, these people don't get it. I think I should write a blog post. And she's egging me on, yeah, you should write a blog post. So I wrote this big, long blog post explaining on why this video is a perfect analogy for the transformation that we make on DevOps. And I'm just going to give you a quick run-through of what I wrote. The increase in the number of people. How many of you remember a small company called Compact Computers? Anyone remember that company? Yeah, all the old people remember that company. Yeah. So that's where I started writing software back in '96. And I've seen a lot of software written. But back then, it was this beautiful time to be a developer. When you were done writing the software, you, the developer, walked over to the production server and you typed in your own credentials and it logged you in. You could actually touch the machine that ran your software. And you could copy files all around, change the registry, do whatever you want. And then when the lights went off, you just point the finger at the ops guy and walk away. It was awesome, right? But now, when you try to deploy software, you're not the only person involved anymore. There's the dev team, the ops team, the QA team, the program manager, the auditing team, the security team. There are more people today involved with deploying software than there was even 5, 10 years ago. So I think this is a perfect analogy for what it takes to deliver software now versus what it did a while ago. But what I thought was even more interesting is I did not see these as people. I saw them as automation. I saw them as the series of tasks that we string together in an automated fashion so that we can move faster. To me, I saw automation as part of continuous integration, continuous delivery, infrastructure as code, configuration as code, the DevOps best practices that we apply to move faster. And when we defined DevOps earlier, and we said that value is the most important word, to deliver value, you have to monitor your application while it's running in production. You can't just assume that the files that you copied were valuable. If no one uses those files, did you deliver value? No. You just copied random files to the server. You need to inspect your code while it's running and adapt to make it better and faster. Guess what? These two gentlemen up here, sorry, let me go back real quick. These two gentlemen at the top never move. These two gentlemen are looking at this pit stop that only took 2 seconds to figure out how they can make it 1 second. They're monitoring from what they're doing so that they can learn and do better going forward. When people are building their DevOps pipelines for the first time, they always talk about, Donovan, how do we roll back if something bad happens? Because in the past, something bad happens and they're worried about it. Guess what? There's a gentleman back here with a jack. And right behind him is another person with a jack. I have a feeling at some point that jack failed, and they wanted to have a rollback and a safety system in their pit stop. It's the same thing that we do in our DevOps pipelines every day. We monitor them, we review them, and we figure out ways to make them go better. Now, the next topic was they did not refuel the car. If your statement is they did not refuel the car, you completely missed the point. It's not that they did not refuel it. It's that they did not have to refuel it. That is a drastically different statement. Trust me, if that car needed fuel in it to finish the race, they would have put fuel in that car to finish the race. They simply did not have to put fuel in the car because they shifted technology to the left. They made the car more efficient, go further on less, better tire management, whatever it was so that they could actually skip filling the car altogether as part of this pit stop. It was not the fact that they didn't refuel the car. It's the fact they did not have to refuel the car. And watching this pit stop again, you realize that halfway through, they were already done fueling the car. That wasn't the slowest part of the pit stop. The slowest part was the tire changing. I've always been taught you should focus on what hurts most first and fix that. And what hurt most was not refueling the car. So let me play this forward. It's 1960 now, and they fixed the tire problem. And they can now switch tires really, really quickly. And what they realize is man, that fuel is killing us right now. Yeah, we dropped from a 67-second pit stop to a 30-second pit stop, but the problem that's killing us right now is the gas. And then they go and they focus on that. Gas is only going to go in the tank so fast. So instead of doing that, let's just not have to refill the car. Let's apply some technology, some innovation to our vehicle so that instead of us having to refill the car, we can do things like this. We can come in and at a blink of an eye, not only change 2 tires, but change all 4 tires and get that car back on the road. This is what DevOps can do for your organization. And this is exactly what DevOps did for our organization. On the Visual Studio Team Services team, we went and had this huge transformation. And I love telling this story because many of our customers are on this exact same transformation. And they love to hear how we learned so that they can learn from our mistakes. Because trust me, we made mistakes. We might be the largest software company in the world, but we are by far not perfect. But what we want to do is show you what we've been able to do, and hopefully you can apply some of those best practices in your organizations as well. How many of you remember Team Foundation Server 2005? Anyone remember that? Sorry, guys. It didn't get much better in 2008 either. I had a job as a consultant. The product was so hard to install, it literally was my job to fly around the world and install it for you, right? That's how bad it was in 2010. And if you notice, we were gone like 3 years at a time, 2 years at a time. That's back when we were stamping DVDs. That is literally us swinging a hammer at a tire, while the rest of the people are just driving laps around us. They're all working on just build, and they're doing it really well. They're working on just work item tracking, they're doing it really well. And our products only worked for 1 language and 1 platform. And we were losing badly. But being a software company, we realized that we had to change what we were doing, otherwise we were going to lose. So in 2013, we made a decision to go back to 2 years. No, of course not. We didn't go back to 2 years. We started shipping every 3 months. We cannot, in an industry like ours, disappear for 3 years and assume that the assumptions we made 3 years ago are going to hold true 3 years into the future. And even 3 months was too long for us. So our on-prem product, the one that we actually ship and you can install yourself, we still produce every 3 months because that's as fast as our customers can even install the software for us. But we wanted to move faster. So what we did is we offered the exact same service online as Visual Studio Team Services. And we shipped that every 3 weeks. We went from every 3 years down to every 3 weeks, and we're still trying to figure out ways that we can move faster. And what I'm going to share with you now is how we changed our people, changed our process, and changed our products to make sure that we could deliver for you the products that we do today. I got a dirty little secret. TFS 2005 and 2008, you remember it, but we weren't using it. Right? And that's a horrible way to sell software. And Satya Nadella said, we have to stop living this fake life where we would write software for others that we would not use ourselves. And he was talking specifically about our product. And then he mandated that the Windows team had to use TFS. The Office team has to use TFS. And damn it, the TFS team has to use TFS, right? So I'm happy to say that Visual Studio Team Services is planned, tracked, built, and deployed using VSTS. And I'm going to talk about how we did that. We were a waterfall shop like many of you are or were. And we decided to make the transformation to an agile shop. We are a pure Scrum team. We're actually 40 pure Scrum teams spread all across the world. Microsoft is broken up into program managers and engineers. And the way that we break them up in Scrum speak is your program manager is going to be your product owner. And your Scrum Master and your engineers are going to make up the Scrum team itself. You bring them together, and what you create is what we call a feature team. And the 40 feature teams that live in Raleigh, North Carolina, Washington, Redmond, and also in Hyderabad, India, build this product for you every 3 weeks. Every one of those teams sits in a team room so that they are co-located so that we don't have to get on Skype or Slack or try to track down someone for a meeting to have a conversation with them. If I don't like your API, I'm going to swivel my chair around and tell you that I don't like your API and that we got to work on it to make it better. If we have a bug that we need to fix, I don't have to go file it in a bug system. I can turn around and you and I can fix that bug right now. When it's time for your daily stand-up, you just stand up because we're all within earshot of each other. You answer the 3 questions, you sit back down, and you get to work again. Outside of these team rooms are 2 other what we call focus rooms that have doors on them, whiteboards, and you can have conference software. If you're in Raleigh and you need to speak to someone in India, we give you the technology to do that. We allow you to close the door so that you don't have to bother the rest of your team when you need to have a lengthy in spirited discussion or disagreement, you can actually close the door and have it privately. But it's a really nice way for them to be able to focus on what they do and have the people that are important to them very, very close. This empty seat here, this is where the program manager actually sits. So even the program manager is part of the feature team and is going to be available to everyone on the team if they need to. Each one of these rooms is very unique. They all have their own culture, and we call it aligned autonomy. The autonomy means that they can do whatever they want in their rooms and in their sprints. We happen to run 3-week sprints, but if you want to treat it as a Kanban flow of work, or you want to treat it as 3 small 1-week sprints, that's completely up to the team. The way that we align you is our sprint length is 3 weeks. And in 3 weeks, your software better be ready to ship. And that's where we're all going to come together and make sure of it. Other things that are unique about these rooms is that they have their own kind of feel about them. This room is very nice. It's quiet. It's clean. People have their headsets on, not to bother others. Not all rooms look like this. This is probably the only one we can take a picture of and share with the public. Because the room that I was in didn't look like this. But the teams loved it. The way that they blew off steam when everyone got frustrated was everyone had a Nerf gun. And a war would literally break out in the middle of the day, and Nerf bullets would be flying everywhere. But that's how the team liked to work. You'd go to other ones where they'd let you eat in the room. Other teams would not let you eat in their rooms. It's just really cool how they all develop their own rules and regulations for every team room. The teams normally stay together for 12 to 18 months, and then we give you the opportunity to move to one of the other teams. 80% of the engineers go back to the team that they were on. They like the culture, they like the pattern, or they like the feature that they happen to be working on. But others rotate around, and it's fantastic because we get this nice cross-pollination of experiences and diverse opinions across all of our teams, which is great. We run 3-week sprints. Do not run 3-week sprints because we run 3-week sprints. There's exercises and experiments that you do to determine what is the appropriate sprint length for you. I wasn't there when the VSTS team chose 3 weeks, so I asked someone that was. And I don't know if you've ever heard of the fairy tale or the children's book, Goldilocks. That's what they said it was. They called it the Goldilocks syndrome. Like, what do you mean? It's like, well, we tried 2 weeks and it felt too small. We tried 4 weeks and it felt too big. And we tried 3 weeks and it felt just right. I'm like, all right, cool. He's like, yeah, because if you look at Scrum and you do Scrum correctly, there's a lot of ceremony in Scrum. There's daily stand-ups every day. There's a sprint planning meeting. There's a retrospective. There's a sprint review. In a week and 2 weeks, that's a lot of ceremony. You just don't feel like you get a lot of time to code. And then when you do a 4-week sprint, in your mind, you're trying to map it to a calendar month, and it never fits. And it really struggles to make sure that I can even estimate what I can do 4 weeks from now. I'm pretty good at estimating a week, 2 weeks, and even 3 weeks. But that 4th week is always fuzzy. Maybe we get there, maybe we don't. So why are we even wasting our time with that 4th week when we're planning? Let's just do 3-week sprints, and we've been doing them that way for years. But again, every organization needs to determine on the external impacts, influences that might determine what your sprint length would be. 3 weeks works really, really good for us. Now, if we were to break down and zoom in on one of our 3-week sprints, it looks somewhat like this. The final hardening of our task and our requirements happens in the first couple of days of the sprint. We sprint then for 3 weeks, and at the end, we start our automatic deployment. VSTS, which is so mind-boggling sometimes, has 6 different rings. So we use safe deployment, which means we deploy out into production, but just to a subset of our customers. We monitor our software while it's there, and then we deploy it to another subset of our customers, and we rinse and repeat until all of our customers have it. But every deployment is into production. It takes about 10 days to do that. But the instance that we use as the VSTS team actually deploys itself on top of itself while we're using it, right? Which is the freakiest thing that happens every 3 weeks. And it doesn't stop, it never fails, and it just keeps on running. And then we go and we rinse and repeat this 6 more times across the, but it's completely automated. As you can see, that deployment is not after our sprint and then before the next sprint. It is literally at the same time as the beginning of the next sprint because we don't have to stop what we're doing because it's completely automated. Now, we do have people who are sort of like babysitting and guarding that pipeline, and we call them our SWAT team. So we take about 2 engineers of each of our Scrum teams, and we assign them to the deployment. So that if there's any hot fixes, any bug fixes that need to go out to make sure that the deployment is successful, we have someone there who can work on it for us. And they have been lightened, their load has been lightened, so they're not responsible for features, they're responsible for the deployment. And that rotation happens every single sprint. Now, one of the questions I always get asked is, Donovan, how in the world, if you have 40 feature teams across the world, do you keep up with 40 sprint reviews? How can you sit in all of them? Well, we don't sit in all of them. What we do instead is we use email. At the beginning of every sprint, the program manager sends out an email saying, this is what my team has committed to do, and this is the plan we have in place to go achieve that goal. 3 weeks from then, we get another email saying, this is what my team was able to achieve, and here is a video that shows you that actual software working. The video has a really cool side effect. We just did it because we simply physically could not be in 40 places at once, and we wanted a way to review the software that the team had actually produced. But you cannot use After Effects, you cannot use Photoshop. That video has to be real. If the software does not work, you cannot put it in the video, which means your team can't wait till the last day to finish anything. They have to finish it several days in advance such that I can then produce the video, which also allowed the program manager to review the code before it actually ended up in the hands of our users, to make sure that it met their expectations, maybe rub a little polish on it to make it better right before we push it out into production. But it was really cool how the video ended up being a forcing factor for our teams to get things done, which is really powerful. So every 3 weeks, I get 80 emails. I get the email saying this is what we plan to do and what we just got done every 3 weeks. So basically, I'm really good at Outlook rules that are able to funnel all these into a certain folder so that I can go back and comb through them when I'm ready. If you've ever used TFS or VSTS, what's highlighted on the screen now is just a work item query. I can literally click on those links and actually go and read about the features that the team is planning to implement. And then 3 weeks later, I get this amazing email showing me exactly what happened and how the code is actually going to work so that all the teams can stay in sync. Next thing I'm always asked about is, how do you plan something like Visual Studio Team Services? Well, what we do is we basically break it up into different segments or different lengths of planning. One of them is called a scenario. We basically stand and say 18 months from this very moment, knowing everything we know about the industry, where should our product be? What features should it have? What performance improvements should we make? How many new scale units should we have 18 months from this very moment? And then what we do is we break that 18-month period down into 2 6-month seasons. One of those seasons just is about to end. When I fly home, tomorrow? I'm going to be racing to Houston, Texas, just to turn around and fly to Seattle for a conference that we have every year called Build. Build is one of our largest conferences, and we want to announce a lot of great stuff at that conference. That happens to be the end of one of these 6-month periods. So the team works on what are the big announcements for Build, what do we want to share with the country and the world, and then we go off and we work on that particular plan. We do it running 3-week sprints until we hit that particular date. 6 months after that, we then basically say, okay, we've had 6 months worth of experience. Now, knowing what we know, where should we be 18 months from this point in time, given all the information that we've learned over the last 6 months? So you're constantly recasting that 18-month vision. 18 months from now, if we were to look back at what our decisions were, if we've only done 60% of that, we feel that we've been successful because the world changes, our environment changes. So you don't have to stick to 18 months ago we said we were going to do this, and now we have to do that. Agile is all about inspecting and adapting, and we do that as often as we possibly can. And we inspect and realize that what we thought we needed isn't what we needed anymore. So don't kill yourself trying to deliver everything when all the statistics and numbers say you need to be delivering something else. So we basically review this over and over again. The second season ends in New York at a conference that we have called Connect that happens every year in November. So if you watch Connect and you watch Build, you're always going to see a lot of great announcements from these teams because those are our 2 6-month seasons. After we do that, we have our ownership, our leadership. So for example, if you remember, Brian Harry used to lead VSTS all up. Now it's Nat Friedman. Nat and his direct reports, they craft that 18-month season for us. They say, okay, this is what that 18th-month scenario is going to look like. We're also going to tell you what we want to deliver at Build and at Connect. And then the team is responsible for making sure that they deliver on that. Now, there's one section in here that I didn't talk about. I talked about the 18-month scenario, the 6-month season, and the 3-week sprint. The other item in here is every 3 sprints, the related teams come together to share information. So, for example, work item tracking, where we have Kanban boards, product backlogs, integrations with different areas of the product. The work item tracking team is probably like 6 teams all together. Every 3 sprints, those 6 teams come together as leads and have a meeting where they describe where they're going to be 9 weeks from now, basically 3 more sprints. I got to sit in on one of those meetings. It was a really cool experience to hear the leads talking about what they've done and where they want to go. One lead said, in the next sprint, we need this new widget. And one of my engineers has kind of drawn up what they believe that widget needs to do, and it's going to do X, Y, and Z. And another lead spoke up and said, interesting, we just wrote a widget that sounds very familiar to that. Why don't you have your engineer talk to our engineer and make sure that we're not about to duplicate things? We would not have been able to share that code had they not come together. What we would have had is 2 people writing the exact same widget instead of having them share that information. So it's really important for us to allow our teams to come together and collaborate in a way like this, which is very powerful. Now let's talk about quality. It's extremely important, and we were just like everyone else. We would try to work towards something called a code freeze or a code complete. Anyone remember code freezes? That basically means please stop typing, because the more you type, the more bugs you create. So if we can get your hands off the keyboard, then we can go count how many bugs you currently have right now. And what you would do is you would go and have a pizza party while you give your code over to the QA team. And the QA team would just go to town on your software, logging bug after bug after bug. And what you're building up is technical debt. Because the developers back when I was young, we didn't write unit tests. We just coded till we thought it was complete. We'd run through it once, it worked, so then I would mark it as done, and then I would throw it over the wall to the QA team. And then when all the bugs start coming rushing back over us, we would do what we call a bug bash. We would pay down as much of that technical debt as we could, and then we would ship the product, and then all hell would break loose. And it looked something like this. It was variable. You had no idea how much technical debt you had incurred because you had never written any unit test. You didn't know how many bugs you had. And that made it really difficult for us to plan because you end up with charts that look like this. The first 2 valleys didn't look too bad, but that third peak completely blew off our schedule. We missed all of our milestones because we had no idea how much technical debt we were carrying. We wanted to change this variable to something that looked more like this, to where we knew how much technical debt we were having. And we could go and pay down that technical debt when it became too expensive. Buck Hodges is our director of engineering. Brilliant man. And he basically makes sure that everything flows through our pipeline very well, and that our engineering team is highly functional. We do not have manual testers anymore, but I'll talk about that in just a second. But one thing that Buck wanted to figure out was, how many bugs can my developers fix in a particular day? And on average, a developer can fix 1 bug per day. And if I want to be 1 week away from shipping, I can't have any of my developers carry more than 5 bugs. But how do I know if they have bugs? They have to be writing unit tests. So we had to change our mindset. There was no longer you get to throw the code over the wall to QA and then hopefully bolt on quality after. You had to now design the quality into the product. The people who wrote the code also had to write the test. Not only the unit test, but even the UI automation test. We came to that phenomenon once because we threw the code over the fence, and the UI automation engineers were taking a really long time to test all the code. And we were like, so what's the holdup? They said, well, the way that the code is written, it makes it very difficult for us to have high levels of code coverage. We're having to write lots more tests than we should to get into all the nooks and crannies of the code. He says, well, why don't you just change the code? He says, because we're not developers, we're automation engineers. He said, that's not good enough. If the code is poorly written, you should have the authority to go rewrite it to make it easy for you to test. So what we decided to do is get rid of our QA team and make everyone an engineer. Make quality everyone's responsibility. You had to be comfortable writing the code and even writing the test for that code, including the automation. That allowed us to have this consistency because now we knew how much technical debt we were having. And if you ever went above the technical debt, what we call the bug bar, you had to stop what you were doing and pay down that technical debt. Now we were always within 1 week of shipping, no matter when we wanted to ship. Now, how did you monitor that bug bar? Well, we actually have statistics that we monitor. These statistics allowed us to look on average and see how many bugs our teams are actually carrying. And if I zoom in on this for you, you can see that these numbers aren't always below the 5 number. Some are above, some are well below. Do me a favor and do yourself a favor. When you start to monitor your developers closely like this, you cannot use these numbers to punish your developers. Developers are very clever people. If you punish me with these numbers, those numbers will magically always look good. But what you're really wanting to do is use these numbers to inspect and adapt your process. You go talk to those who are having trouble staying below the 5 bug bar, and you ask them why. Were you overloaded? Was it just bad estimating? Were you using new technology you were unfamiliar with? Do we need to give you more training? Because if you can't stay below the bug bar, it's actually my failure as management, not your failure as an engineer. And you got to treat the numbers safely that way. That way you get accurate numbers that you can actually inspect and adapt to, not numbers where people are going to run from and game the system. Now, we did more than just track our bugs. We also had to go in here and track our performance as an entire organization. One of the things that I get asked a lot is like, okay, Donovan, I hear what you just said, right? You said you took developers and you made them responsible for tests, but historically, developers are horrible testers, right? They basically write the code and then they test the code to prove that it does what they wrote it to do. But they don't test that it handles bad scenarios, null values, empty strings, dates that are supposed to be numbers, numbers that are supposed to be strings. They don't test for any of that stuff. So how did you make a developer who always plays nicely with their own code good at testing and breaking it? I said, we wake them up. Like, what do you mean? In a DevOps mindset, if you wrote the code, you run the code. That means no longer does the developer get to write the code, throw it over the wall to a QA team or to a ops team, and then go to sleep and sleep through the night while the ops team is fighting fires because the code is no good. And then the developer wakes up, oh, rested, nice sleep, and then goes in and sees a bug. I'll get to that bug later. And that night, the poor ops person is fighting the exact same issue. So the developer is not paying the consequences for their bad decisions. If I don't have to pay the fine, I'm going to keep speeding. So what we decided to do was make sure that the people who made the bad decisions had to pay the consequences for those bad decisions. So they had to start wearing a pager. So at 3 o'clock in the morning, when the ops person gets a bad call, the person who wrote that call also wakes up. Guess how quickly our quality went through the roof? Because as a developer who wants to sleep through the night, if I realize that the reason I had to wake up is because I did not check a value before I tried to cast it to an int, because it actually said Donovan, and I tried to cast it to my age, and it blew up, next time I'm going to do try parse instead. Right? I'm going to write the code to be a little bit more defensive because I want to sleep through the night, because I'm now paying the consequences for my bad decisions. Another way that we taught them to pay really close attention is when I went back and I said VSTS is used and built by VSTS. That very first ring, we have 6 rings that we deploy to, that very first ring is the VSTS team. If we write garbage, we're the first ones to get it. And it risks us being able to do our job every single day. We deploy it into our ring, and it sits there for 24 to 48 hours while we're monitoring telemetry, we're checking for new bugs. And if it can survive the VSTS team for 48 hours and not have any issues, we then give it to our regional directors, our VPs, and our other groups of what we call friendly developers, people who have elected to take early bits and are going to give us feedback. If it can finally survive them, it goes off into what we call our first public one, which is Brazil. They basically get the bits before anyone else in the world. And that's where we get to see a lot of load put against the system. We get to check our telemetry for performance. We get to check for things called LSIs, which is a live site incident. And we measure those on a completely different chart. This chart lets us know if we've had an LSI. Again, that stands for live site incident. That's where we have our system stop performing and achieving the goals that our customers need it to achieve. And the way that we want to monitor that is how quickly did we find it? Was it our telemetry that told us, or did we get an email from a customer? How long did it take us to mitigate that problem, which means at least get the system back to a working position? How long did it take us to root cause that particular problem? And how long did it take us to put in the long-lasting fix? We're extremely transparent about these numbers. Every time we had an LSI, Brian Harry would write an email explaining to our customers why our system failed, how our system failed, and what our engineers are doing to make sure that failure never happens to you again. We have a lot of proud developers, but nothing hurts worse than your manager having to write an email to apologize to your customers for your mistake. So again, the pride that we take, the consequences that we put upon ourselves to make sure that we are valuable and that we are writing valuable software for our customers is really important to us at Microsoft. Again, you do not punish with these numbers. As a unit, as a team, you work to make them as green as you possibly can. This is a joint scorecard. The ops team does not own this alone. The developers also have skin in the game when it comes to making sure that our systems are effective. I also mentioned that we don't have manual testers anymore. We got rid of our QA team. And the reason that happened is we're very unique on the VSTS team. We write software that we actually use. We are our own first customer. You don't need manual testers when you're going to use it for 48 hours doing your real job. You are your manual testers. Now, unfortunately, if you're not writing software that you actually use in your daily job, you don't have the benefit of not needing a QA team. So I'm not saying go back and fire your QA teams. I'm saying if you're in a unique scenario like we are, you have the advantages of doing things like that. I wanted to start doing some recaps here. One of the things that we had to do that I think is really important here is I just talked about the fact that we no longer had dev and QA. We have engineers now. Those who are responsible for the software and also responsible for the quality that is actually designed into that particular software. Another thing that I wanted to talk about here is the way that we do our testing now. Historically, when we had the QA team and we had the automation engineers, we had somewhere near 27,000 automated UI tests. Not once in history did they all pass. Never once. So eventually you just stop looking at them. They're slow, they're hard to write, they're hard to maintain, and they're unreliable. So why are we wasting time running 27,000 functional UI tests that never all go green anyway? So what we decided to do is that we're going to switch to unit tests instead. Unit tests allow them to run quickly and much more reliably. We run 79,000 unit tests against every pull request given to VSTS. So if you go change one line of code in VSTS, 79,000 unit tests will be run against it before it will even survive a pull request. And we do that 600 times a day on the VSTS team. It's staggering. That's just the first line of defense. If it survives that nearly 80,000 unit tests, human beings will finally review your code. If they approve it and they merge it into master, we start running another battery of tests. And we start running integration tests, still using a unit test framework. But now we let you test the database. Now we let you call out to a web service. We actually deploy the service and allow you to actually use it, but we're using it in a much more reliable way. It would take us 22 hours to run 27,000 UI tests, and now we can run in less than 18 minutes 79,000 unit tests and get a higher level of code coverage. Right? That took a re-architecting of our software. People always want me to come on stage and say, oh, this is what you do. You buy VSTS and all your DevOps problems go away. It's not how it works. You have to re-architect your application in many times to make sure that you can move at the speed in which you want to move. I'll give the example of microservices. Historically, if I'm one service and this gentleman is one service and you're one service and you rely on him and I rely on you, you have to go first, right? And then you can be deployed, and then I can be deployed. Our deployment just got more complicated because I have to orchestrate which order everything goes out. And if they go out in the wrong order, we might have problems simply because the dependencies weren't resolved correctly. But what if the same dependencies exist, but I can deploy them in any order that I want or even in parallel? That takes a design decision. That is an architectural change such that your web services and microservices are resilient to the fact that what I want might not be there yet, but I have to be able to still survive. And once that new feature is there, I can start utilizing it, but I don't die if it's not. Now I can deploy all my services at once. And as they start to negotiate the communication, everything just magically starts to work. VSTS is up to about 32 microservices at this moment. And we can deploy them in any order that we want, in any time that we want, because they're smart enough to communicate with each other. And if you're interested in how we do that, I have a show on Channel 9 where I sat down with the architect that built our web services for VSTS, and we talk about this at length. So it's really interesting to make sure you understand that it's not just about putting tools in place. It's not about just changing your process and changing your people's attitude. Sometimes you actually have to change your architecture to make sure that you can move at the speed that you want to move. When you're running 24/7 software, there is absolutely no downtime available. VSTS is used all over the world, which means somewhere it's business hours. We cannot take it down to upgrade it. Again, that is an architectural change. If the software was not written to be upgraded while it's running, you can't simply just upgrade it while it's running and expect it to work. We had to go back in and design the software to be able to be deployed onto while it's being used and not go down. This includes the web services, the front end, and including the database backend. We can actually deploy a new database schema while you're using the app, and you'll never know that we're doing it. In the worst case scenario, something that used to take you a 3 millisecond time frame might take you a second if you happen to hit that system the instant that we're upgrading it. But it will not fail. You will not get a retry. Your request will succeed. It'll just take a little bit longer than it used to. But we have to make sure that our customers have an amazing experience with zero downtime. Same thing with debugging. With TFS, the product you install on-prem, it's easy to troubleshoot that. You send me a bug report, I install TFS, I set a breakpoint, I debug the problem. You cannot put a breakpoint in VSTS. If I did, everyone would stop using it and wonder why the system is just sitting there while Donovan's F-sexing through his code, right? Horrible experience. So how do I then go back and troubleshoot a system in one that I can't turn off? Well, we have to collect a lot of telemetry. On average, we collect about 7 terabytes of telemetry every single day on VSTS. We have petabytes and petabytes of data that we comb through to make sure that we can reproduce these problems without ever impacting our users. Another thing that's important about that telemetry is that we should know something is wrong before you know that there is something is wrong. We're monitoring our queue times. We're monitoring the stress on our systems. We're monitoring the response times. And if we start to see movement in those numbers, we can go start taking corrective action before our customers even realize something is wrong. It goes back to the monitoring that I talked about earlier. Monitoring is gold. Not only will it allow me to keep my system up, it'll allow me to keep my customers happy. It goes back to making sure that you deliver value. We've all been on that team where the marketing person runs in or the sales guy runs in and says, hey, stop what you're doing. This is going to make us rich. You move heaven and earth, and you add this new feature, and you ship it, and you have no idea if that actually did what they promised it was going to do. But now we have the technology. Dynatrace has the technology. Put in custom telemetry, right? So yeah, okay, I'm going to go ahead and do this for you one time. Right, I'm going to go ahead and add that new feature, but what I'm going to do is I'm going to put a counter in there that lets me know every single time someone uses it. And then I'm going to push it out, and I'm going to monitor those numbers. So the next time you come running into my office, I can call BS on you. Like, yeah, you remember the last time you told me to do this? 7 people have used that feature. I know you're full of crap. I'm not going to listen to you anymore. And now that you have the numbers to back it up, there's no argument that they can make for you. But if you just think it's a bad idea, but you don't have the proof, you're basically going to be in a losing argument. So use telemetry to your advantage. We do it at Microsoft, and I encourage everyone to do the same thing in their systems as well. It just empowers you to make better decisions. The way that we deploy our services is because we have very clear contracts, and our contracts are versioned. The reason that I can deploy all these in any order that I want is because we've already agreed that version 1 of my API looks like blah, and you promised me that that version will never, ever change. So even if I'm looking for version 2 and I don't find it, I can rely on version 1 to be there, and I know the shape of it. And I'm just going to keep asking you for 2 until you're finally upgraded and you start giving me the data that I want. But again, that is an architectural change, not just a tooling change. Another thing that we do is we use feature flags. We do not roll back on the VSTS team. And I should always have like a little asterisk pop up when I say that, because it's almost true that we never roll back. Once we touch the database, rollback is gone. It's not even an option anymore. If we roll out the front end, which we do first, even if there is a database change, we roll out our front end first, and our front end is actually strong enough to run against the old schema and the new schema. If it doesn't stand up against the current schema, we can roll back the front end very, very easily. But we very rarely have to do that. But once you touch that database schema, rollback is off the table. So then the question is, well, what if you roll out a database schema and something bad happens? How in the world do you recover? We use feature flags. Feature flags allow us to basically control the exposure of a particular feature, such that if it were to cause an issue, we simply turn the feature off, and all of a sudden your system is reliable again. You don't have to roll back anything. You just turn off the affected piece of code. Feature flags are also important when you're working on a feature that takes more than one sprint. I've had so many customers of ours struggle with items that simply do not fit inside of their product backlog. It's like, man, we can't do this in one sprint. It's going to take 3 sprints to do this. So what do? They create a branch, and that branch lives for 3 sprints, all on its lonesome. Not realizing that master is being checked in by 40 other teams constantly. And then 3 sprints from now, you're like, we're done. Let's merge it in. And then boom, you have this merge bomb explode. And you're so frustrated by how far along the code is from where you were that you feel like you're never going to get through all these merge issues. And getting through them can be very risky, because if you actually merge incorrectly, you could be introducing bugs that were never there before. Feature flags fix that. Because let's say, again, we have a feature that's going to take 3 sprints for us to design. But we create a feature branch, and we immediately put in a feature flag. That feature flag allows us to run the existing code until the new code is ready, but I can merge that back into master immediately. You can even deploy this code out into production, and no one will see the new unfinished feature. It's completely harmless. And then once the feature is finally done, when I've been constantly merging into master, so there will be no merge bomb, we simply allow the code to go out into production, and then we turn the switch on. If all hell breaks loose, you just turn the switch back off. And then you go back in, you add a fix to it, you push it back out, and you turn the switch back on again, and you monitor your system's health. When the system is running on all cylinders, sprint after sprint after sprint, you can go back in and you can clean up that feature flag. Feature flags are amazing. There is no way at Microsoft we could move as fast as we do without them. But do not believe that feature flags are free. There is technical debt that comes with feature flags. Technically, a feature flag is just an if statement that is monitoring some external value to see if it's true or false and runs one path of code or another. Eventually, you have to clean them up, and it increases your cyclomatic complexity. And I'm not trying to scare you away from feature flags, because we could not survive without them, but I do not want you going into it lightly. We wrote our own system, but you don't have to do that anymore. There's services now that you can employ that will actually give you feature flags as a service. Feature flags are not only good for long features that need to be developed, they're not only good for being able to mitigate disasters, they're also good for marketing. Like I said, in 2 weeks, I'm going to be at Build, demoing some cool new features for you that are already in the product, but you simply can't see them. Because we've turned the feature flags on for me so that I can start to rehearse and prepare. And on that day, when Scott Goo makes that announcement, we're going to be able to turn that feature flag on, and everyone in the world is going to be able to enjoy it. And if it goes bad, we'll just turn the flag back off. Feature flags are awesome. That same show I talked about before, I have a show on there about feature flags as well. And I encourage you to go ahead and watch that to learn more about what we do here at Microsoft. So that's what I wanted to share with you. Don't think that you have to be perfect. Microsoft was not perfect. We've been on this journey for 7 years, and we're not done yet. Thanks to Windows containers, we're going to even be able to move faster than we did before. We have slowly and methodically been teasing apart a monolith to make sure that it is well-written microservices architecture, born in the cloud, that we can deliver to you extremely fast. So I hope that you were able to learn something from that, and you enjoyed this keynote, because I've really been honored to be here and share this time with you. Thank you so much.